So we spent yesterday or our last lesson talking about the law of sines. So the other important law that we have to look at is the law of cosines. Okay, it's a little more difficult to remember, so I'm going to try to give you some tips along the way to help remember what the laws are. You do have to commit these laws to memory. They will be useful in the future, especially next year in your courses. Okay, so let's take a look at the law of cosines. So the law of cosines, again, works when triangles are not right triangles. So we're looking at that same triangle that we were looking at yesterday, triangle ABC. And what the law of cosine says, a little different, okay? It starts off looking like Pythagorean theorem. C squared equals A squared plus B squared, okay? But here's where things get a little different. It's got a little added extra piece to it. Minus 2AB cosine of angle C. So that's what the law of cosines looks like. Now, it can be written, even though we tend to look at it like this, it can be written in a bunch of different ways. So a couple other ways it can be written. It can easily be written as A squared equals C squared plus B squared minus 2CB cosine of angle A. Notice what happened here, okay? When I changed the letter that was here, the side, I also changed the angle. So now we were with angle C or side C across from angle C. For the second time I did it, side A across from angle A. So whatever side is here, you're using the opposite angle over there, okay? Which means that I could do this for B as well. So that would be A squared plus C squared equals, or minus, sorry, 2AC cosine of angle B. So the way it works out is basically one side here, the other two go there, kind of like Pythagorean theorem. Then these two sides are the same two here. And the opposite angle of that side is the one that we use to cosine. I just basically try to remember it like this, okay? Because I can change the letters however I want. So Pythagorean theorem and this extra piece tacked on. That's what the law of cosines is. Now that we know that, how can we use it? So let's look at a problem. Whoops, forgot to get my little drawing piece here. Okay, forget it. We don't care about that. Let's look at a problem. So here we want to find side C. Now notice angle C is across from it. So side C squared, start off like my Pythagorean theorem, 11 squared plus 8 squared. But it's not Pythagorean theorem because it's not a right triangle. Minus 2 times 11 times 8 times the cosine of the angle that's opposite side C. So that's 37. Now the calculations here can be daunting. If you try to punch all of that into your calculator, you're probably going to make a mistake. So take it step by step. 11 squared is 121, 8 squared is 64. So I can quickly go and do that. So let's see, that's 121 plus 64. That gives me 185. So I'm going to start there. C squared is 185 minus 2 times 11 times 8. So 2 times 11 times 8 is 176. Cosine of 37. Okay, well, I have to do this. Remember, order of operations, you have to multiply before you add and subtract. So since I got to multiply 176 times the cosine of 37. Remember, cosine of 37 is a number. So I got to do multiplication first. So 176 cosine of 37. Make sure I'm in degrees. Haha. Okay, so 176 cosine of 37. So that's 140.5598. So 140.5598. I still have the 185. And now I can do my subtraction. Okay. So that's 185 minus, and I'm going to copy and paste this. So copy it, Control C, paste it, Control V, 44.4402. 44.0, what was that? 0.4402. 0.4402. Okay? But that's c squared. I need to take the square root of that now. So c will equal, so I'm going to go back to my calculator, take my square root, so my square root, and again, copy and paste. I'm going to get this, oops, get that and copy it, and paste it. And there we go. 66.6663. So 66.6663. There's my side. Okay. Oh, they said angle C. That should have been side C. We already know what angle C is. So there's my side. Okay. Simple as that. Now, what information do I need to use the law of cosines? That's important to know because we talked about the information needed on the law of sines in our last unit. So for the law of cosines, both things require 4 things. So for law of cosines, I need one angle and 3 sides. Now remember, one of these things is the unknown, or is what we're looking for, okay? So even though there's 4 things, I say we need to know those 4 things, any one of those 4 could be my variable. The other 3 have to be solid numbers. They have to be numbers I know. And don't have to be whole numbers, but they have to be some form of number that I know, okay? All right, so why don't you try one? Here's your problem. Find the length of side AC. Go for it. So side AC is my variable. I'm going to call it, since it's across from B, I'm going to call it side B, just for something to call it. So B squared equals 66 squared plus 100 squared. So that's basically the Pythagorean theorem part. Minus 2 times 66 times 100 times the cosine of the angle that's opposite that side, so 25. All right. Once you've got that written out, now we can start trying to figure our way through all of it. So let's take care of this 66 squared plus 100 squared. I'm going to go to my calculator. 66 squared plus 100 squared, 14,356. 14,356. Okay. Now I'm going to take care of the 2 times 66 times 100. So 2 times 66 times 100. 13,200. Cosine of 25. Following my rules of algebra, I multiply to 13,200 times cosine of 25. So 13,200 cosine of 25. 25, right? That was the angle? Yes. Big number, 11963. Let me write all this down. 3, 5, 6. So that was 11963. 2628. All right, so there we go. Lots of information. Now we want to subtract. Okay, so I'm going to go to my calculator. I'm 14,356. 14,356. That one I can type in. Minus, I don't want to type this in, so I'm going to do my little copy and paste here. Copy, paste. So 2392. So that means B squared is 2392.7372. 7372. And you notice how I'm writing all this information down. I'm not just calculator, because if I mess something up, I want to be able to go back and find my mistake. So I do write all of this down. Now I square root both sides. So let's see, that's going to be square root of, let me get this answer here. Copy, paste. So 48.9156. 48.9156. Make sure I wrote that down right. 9156. Okay, good. There we go. There's our B. Or side AC. So not too difficult. It's a little tedious, okay? So let's take a look at one more type of problem, a couple more maybe. Because on both of those, we found sides. We can also find an angle if that's what's missing, okay? So when I look at this problem, the angle I'm looking for is x. So I'm going to be doing the cosine of x. But what side goes on the equals to side? The 16, okay? So when I set up my formula, I've got 16 squared equals 22 squared plus 8 squared minus 2 times 22 times 8 cosine of x. Okay, so basically we set up the same formula. The important information in my formula was that I said, okay, if I've got, since that's across from there, that's going out here. The other two sides go into the rest of the formula spots. Okay, so now it's just a matter of calculating. So let me pull up my calculator here. Let's see. You know what? I'm going to try to minimize this a little bit so we can see both things at one time. Man, let's go over to here. Boop. All right, so here I've got 16 squared is 256. So that's 256. 22 squared plus 8 squared. 22 squared plus 8 squared. 548. Minus. So let's see what else is written under here. Okay. So minus, now I've got to get 2 times 22 times 8. So that's going to be 352 cosine of x. Okay. So we're just working to our algebra here. Okay. To do this, I'm going to subtract the 548 on both sides. Okay. So that's going to be 256 minus 548. So negative 292 equals negative 352 cosine of x. Okay, so negative 292 plus 352 gives me 60 equals cosine of x. And now I just need to do x equals cosine inverse of 60. Now let's see if this works out for us. So cosine inverse of 60 degrees comes out as undefined. So that turns out that this triangle doesn't actually work. That can actually happen. I'm just going to go through and double check all my arithmetic to make sure that I did everything right on that. So let's see. Just double checking. So 16 is 256, 22, 8, that's 548. Okay, that's set up there. So far, everything's looking good. And then we did 256 minus the 548. Good. Oh, nope, that's, oh, stupid me. Right here's my mistake. We're not going to subtract that. Let's correct that. This is what happens when you get things that don't make sense. Go back and see where your mistake was. My mistake was that I shouldn't have subtracted. I should have divided by negative 352. So let's do that again. So negative 292 divided by negative 352. Okay, now we're getting somewhere. So 0.8295. And that is the number I want to do my cosine of. Okay, so 0.8295. So I want the cosine inverse of that. Cosine inverse, whoops, of copy, paste. Now that's a better answer. X equals, we'll just call that 34 degrees. So hopefully not only have you seen some stuff with the law of cosines, but also you see what happens when you make mistakes. Don't just assume, oh, the calculator's right. Go back and find your mistake, okay? If I had said there, oh, this doesn't have an answer and kept on going, I would have been wrong. go back and find your mistakes. That's important. We all make those mistakes. Now that we have our answer, though, we're good to go. Okay, let's try one more problem like that, okay? I'm going to go a little larger here so we can see the full screen on this one. So two cell towers are 6,000 feet apart. So I've got two cell towers that are 6,000 feet apart. Your cell phone is located somewhere here, and it's this direction from that tower, that far from that tower. This is actually how people can locate your phone. We can now find the angle, okay? So I need to find the angle. I want to look for the angle created at Tower A, so at my first tower. Let's go ahead and give that tower a name, okay? Let's call this is our Tower A, and this is Tower B. And we want the angle created at that. That's what they said. Okay, so, again, first locate. There's my lonesome side, okay? So that's the side that I'm going to start off with. So I'm going to write out my formula now. So 2,420 equals, these are some big numbers. Good thing we got calculators. Squared. Don't forget the squareds. The other parts of these, like I said, just like Pythagorean theorem, minus 2 times 2,420 times 50/50 cosine of the unknown. Okay. Okay, big numbers. So I'm going to go off to the side, minimize that sum, and we're going to get some numbers on my problem here. So let me pull that over so I can see a little better. So let's see. Let's start off with the 2420 squared. 2420 squared. Bam. Big number. I knew it was going to be big, but that's okay. 5,856,400. Okay. 50/50 squared plus 6,000 squared. So 50/50 squared plus 6,000 squared. Now the big number, 615,025,000. Sounds like a phone number. Now I'm doing the other part. Whoops. Notice a mistake I made again. I put in right here, I put the wrong number in my formula, didn't I? That's not what I wanted. I want to put the 6,000 in there. So let's correct that right now before I make a mistake again. Let's take that out. Let's put the 6,000 in there. There we go. So now I'm going to say 2 times 6,000 times 50/50. So that's going to be 6,0,600, and then 3 more zeros. Cosine of theta. Okay. Big numbers, but that's okay. I'm going to use my copy and paste quite a bit here. So I'm going to subtract this 6,000 from both sides. Actually, that's 5,856,400 minus 615,025,000. And there's my new number. Let's see. Let's scroll up so I can see my whole screen. So I've got negative 55646100 equals negative 60,600,000 cosine theta. Okay. Now I do my division. So I'm going to take this number here. Let's copy it. See if it copies to -2. It did not. Let's put that negative in front. Divided by this number here. Put the negative in front that time. I knew it wasn't going to do it. And there's my answer. So 0.9183 equals cosine of theta. Now we do our cosine inverse. So theta equals cosine inverse of 0.9183. So I get my functions, cosine inverse of copy, paste. So I believe they said to the nearest degree. Let me scroll back up to the top here. To the nearest degree. Good. So my theta equals 23 degrees. Okay. So it is, yeah, you can get some big numbers and it's a lot of work. You could have actually made this smaller by, since all of these have, think about your similar triangles. Similar triangles, you can use smaller sides. So I could have actually knocked the 0 off of all of these and it would have made my numbers a little bit smaller. Okay, that's just taking that down and dilating it down some. You still keep the same angles, so the problem doesn't change. Okay. Tough problems, but I think you can handle this. Tonight's homework is just a few problems dealing with the law of cosines. Okay. Next lesson, we'll look at how I know how to use which law. Okay. Good job. See you later.